Hi folks, Matthew Lanigan here with BayWa RE. I still see people signing in. We'll just give it another minute or two and we'll be right back with you. Thanks so much. Hi folks, Matthew Lanigan here again with BayWa RE. I'm the Chief Commercial Officer here at BayWa. Really appreciate y'all taking time out of your busy day to be with us and our great partner APsystems and to learn about their storage products. Just before we get started, just a note, this will be recorded. This will be put up on our YouTube page. If you haven't signed up for our YouTube page, we would love that you do that. Also, it'll come out in the monthly newsletter. Continuing education is very important to BayWa. We do it a lot internally and are happy to share that with you folks as well. We will be taking questions. You'll notice there's a questions box down in the bottom right corner. If I could just have somebody say hello in that box just to make sure everything is working well. Great, thank you. So without further ado, I'd like to introduce our friends APsystems. They've been fantastic partners of ours. We've been dealing together for about a decade now. So without further ado, I'd like to introduce Chris Ling, Applications Engineering Manager. Chris?
Hi everyone. Okay, so bear with me 1 second. Okay, just to check, you can see my screen?
Yes.
Great, yeah. Thank you. Okay, I guess I will proceed. So, hello everyone. My name is Christopher Ling. I represent APsystems, and I'm an applications engineer. And today I will be talking about the APsystems storage solution. So just as a quick overview, APsystems has been founded in Silicon Valley at around 2010. So as you can imagine, our partnership with BayWa has been a decade. So BayWa has been one of our early partners. We are a global provider of what we call MLPE, or module level power electronics equipment for the solar PV industry. We have a lot of different research and development centers in the US and in China, but we also operate our business units in different locations all around the world. So that includes in USA, we're based in Austin. In EMEA, we have offices in Amsterdam and Lyon, and so on and so forth. So not just the United States and Canada, we do have a pretty large global presence in terms of our power electronics for solar. Some interesting key facts. We are #2 solar microinverter supplier worldwide. #1 in terms of multi-module microinverters. I believe this number is now out of date. The number has increased. But as of the time of this site was written, we've installed more than 3.5 gigawatts of solar. So that's more than 2 million microinverters. So probably a lot more now. And as mentioned, our customer base is 100 countries, and then we have third-party financing with these companies.
And you are right, Chris. It's actually over 5 gigawatts and more than 3 million microinverters at this point, and I think 500,000 installations.
Awesome, thank you. Yeah, and that goes to show like how I think this is written in either 23. So that really goes to show the exponential growth of not just solar, but also APsystems overall. So just as an overview, this is probably what a lot of you are very familiar with, which is the APsystems residential solution for solar. So that basically includes the main star is the DS3, which is the micro inverter that takes in 2 panels and outputs 240 volts. And that basically is a microinverter that is our bread and butter at APsystems. We also have our ECU-R, which is the energy communication unit, or the gateway device that communicates with the DS3s wirelessly through Zigbee and uploads the data into the cloud. And then you can access the data through the cloud through what we call the EMA, which is the website or a mobile app where you can access the data. But this is not the focus of the webinar today. In fact, what we're most interested in talking about is the APstorage. So I'll first go over a couple of examples of some sites that we have. So these are some initial sites where we have the ELS 11.4K our APstorage solution here, and it's currently paired with the UZ batteries that we're showing in a picture. This picture on the left side is one that's installed inside of a garage. I think it's in Utah. The site that's shown on the right side is an outdoor one, but there's like a overhang above, and it is based in Arizona. And then this picture over here is in SoCal, and then I have the picture on what the wiring looks like on the right side, just to get a better view on what it looks inside. So these are once again just overview photos of what these installations sort of look like. And I'll go a little bit more into detail what each one of those components do and what are their functions. So first off, I will set a primer in terms of defining commonly used terms within the storage, within the home backup storage lexicon. A lot of these are probably basic, but I want to make sure that we're all sort of on the same page. So first off, when I use the term battery, I will be referring to a DC voltage electrical storage unit. There are products out there in the market that are batteries that output AC, but for the purposes of this presentation, I'll be saying the battery as a DC voltage unit. Another terminology I'm going to be using is PCS, which stands for Power Conversion System. not to be confused with power control system, but this is a power conversion system. Another name for the PCS can also be a battery inverter. So what it basically is that it's a bidirectional AC-DC inverter that takes the DC battery and converts it to AC voltage so that it can be interfaced with the grid. It's almost like a microinverter, where the microinverter is the AC-DC linkage between the DC solar panel and the AC grid. It's very similar, but the main difference is the PCS, or the battery inverter, is bidirectional. So it can also, not only can it output power, it can also input power to the battery. The third terminology I'm going to use is ELS 11.4K. So this is an APsystems branded PCS, or battery inverter. ESS is a energy storage system, and an AC coupled ESS is going to be comprised of a PCS and a battery. So when you have both a PCS and a battery, you will have an AC coupled battery energy storage system that allows you to charge and discharge from the grid. So just as a first generation, this is the first generation APstorage product that we have and we've sold already in Canada and US and all around the world. It's called the ELS 5K. The E stands for energy storage system. L stands for low voltage battery input. So typically that's a 40 to 60 volt input. S stands for split phase or single phase. And then 5K is referring to the output power that the system is capable of backing up. But today we're not going to be talking about the 5K. Today we're going to be talking about the 11.4K. So the acronym is identical, but the biggest difference is the output power that it can output, which is 11.4 kilowatts. So first, let's go over the main star of the show, so the PCS, or the ELS 11.4K. As mentioned earlier, it's a battery inverter, so it is a AC/DC, bidirectional AC/DC inverter for the DC batteries. The batteries that we accept are low voltage, so it's going to be ranging from 40 volts to 60 volts. If you want to add additional batteries, it is possible to put them in parallel to give the system more time to stay on backup. The nominal output of this inverter is 120/240 split phase, so it does the voltages natively. The continuous power is 11.4 kilowatts, and the peak power is going to be 17.1 kilovolt amps for 10 seconds. The maximum amount of solar that you can charge when you lose the grid is 14.2 kilowatt. This is going to be AC side, and that corresponds to around 3 20 amp strings. And the other nice thing is that the uninterrupted power supply level switching times is going to be very fast. So it kicks in less than like 10 milliseconds when you lose the power. One other thing I also note here is that in the 11.4K, it also disconnects itself from the utility when there's a grid outage, so that it does not provide any backfeeding to the system. Okay, I will pause here since that was definitely a lot of information regarding the ELS 11.4K. But feel free to ask any questions in the Q&A session, and I believe Matt will ask me if there's anything that pops up.
Yep, we're not seeing anything at the moment.
Okay, not a problem. I'm sure there'll be more questions further down the line, and we'll go more into details. All right. So the next component, if we remember that the storage system comprises of the PCS and a battery, this is so the nice thing with APsystems is that we have a list of compatible batteries that we work with, but this is one of the particular batteries that we offer that will work with our PCS off the bat. So for this one, the model name is called APbattery, 51.2 volt, 10.24 kilowatt hours. In the name, it's is written on the tin. It's pretty clear on what the main key parameters are. The rated energy is 10.24 kilowatt hours. The nominal voltage is 51.2 volts, so it's a low voltage battery. The maximum you can put is 16. In general, I would probably recommend most systems will probably have 2 of these batteries in parallel. So for an 11.4 kilowatt PCS, I would probably put 2 10 kilowatt hour batteries. So that would give you 20 kilowatt hours of backup. These batteries are IP65, so you can put them outdoors. Just main thing is I have a picture that shows this, but ideally you have an overhang to somewhat weatherproof it. I have it listed as UL 9540 certified with the ELS 11.4K. It is currently UL 9540A tested. It will be 9540 certified by the end of, I believe, middle or end of this year for sure. So this will be very critical for utilities that have any sort of UL requirements. The battery also has self-heating as well. So in case you're installing these batteries in a climate where it's extremely low temperature, the batteries will be able to warm up so that it will be in the proper temperature range to output power. And then as below, this is the discharge temperature range. I realized I wrote this for United States where we use Fahrenheit up here. I think I probably should have left it in Celsius, so sorry Canadians. All right, so this is the system diagram on how the system is put together. So let me see if I can pull the laser pointer here. So on the left side is where the battery, so the unit that I was talking about earlier, is going to be connected to. This line here is DC, and it's going to be DC connected to the PCS over here. All of these lines over here are AC. So this is where the utility comes into, so where the main panel lives. This is where your backup loads are going to be. So whenever you lose the grid, you will have power that will continue to produce in the backup side. And then furthermore, you will also have solar that will also be connected in a specific off-grid section over here. So that way, when you lose power, you will also be able to have solar when the system is off. In terms of interfacing, the PCS is also going to be connected to the internet. So that is basically how you will have continuous monitoring from the PCS to the router and uploads the data into the EMA portal. So the same exact website and monitoring system that is used for our microinverters. Another thing to note is that the EMA app is able to communicate with the PCS locally. So if you have a phone and you have the app downloaded, you can go nearby the PCS within Bluetooth range, connect to it via Bluetooth, and you'll be able to access the PCS. For those people who are familiar with our 5K solution, it's a little bit different. Because the 5K uses a hotspot that you connect to, kind of similar to our ECUR. For our PCS, it's actually different. It's going to be using a Bluetooth connection instead. So I would like to talk a little bit about our competitive advantage of using this type of a architecture. So first of all, it's all-in-one app if you're using APsystems microinverters. So if you have APsystems micros and you're using the APsystems EMA portal to monitor the micros, you'll also be able to use the exact same tool to monitor the battery system. So customers that already have APsystems product, it will be a very good pairing with those micros. The other thing is that this is an AC coupled or low voltage DC system. So I'm going to be slightly philosophical about APsystems general design principles. With our microinverters, we are strong believers in an AC coupled, low voltage, safe and easy to configure and expand solution and that's with our microinverters. We recognize that there are benefits for like DC coupled solutions in terms of efficiency, or with regards to efficiency, but from our side, we're on the side where AC coupled allows you more flexibility and more safety, and more resiliency in terms of your systems. We feel the same way with our storage solution as well. So that has what was that was what was defining our storage solution. We have seen some systems in the market where they're a DC coupled solar and battery system, and we've also seen systems where they have high voltage batteries, but we try to stay away from those. There are a time and place for high voltage DC coupled, but from our side, we believe that an AC coupled and low voltage DC is easier to install, because you're not dealing with high voltage DC, so there's less risk for arcing and safety. And you'll also have more versatility with an AC coupled architecture. So another advantage with APsystems is that it's a good retrofit. So it's really easy to add to existing installations when you have an AC coupled architecture. It's also versatile in terms of charging, so you can charge the batteries either off of the grid or from the solar panels. It's also multiple points of failure, kind of like our micro inverters, where if one micro goes down, the other micro still continue to produce. Same thing with our storage as well. So if the PCS storage solution does go down, it does not take down your solar system. It continues to output power back to the utility. And furthermore, we also have we're also battery agnostic. We do have a list of batteries that we are compatible with. So if you don't want to use our AP battery, we'll be slightly sad, but it's understandable. But we do allow you to work with other batteries with our system. Oh, and I guess just to explicitly show what that would be, so it would just basically replacing this block and communicating with the PCS. The compatibility listing of our batteries is as follows. I won't go each one of them in details, but these are the ones that we work with. The main thing is that these batteries are low voltage, so once again, they output a DC voltage between 40 to 60 volts, and they're also a closed loop communication. So our battery does need to be able to communicate with these batteries to manage charging and discharging currents and getting battery telemetry data, like state of charge, state of health, and things like that. Next, I'll be going over how to mount the system. So once again, since these systems are outdoor rated, we generally ask that there is like a little bit of overhang over the system to make sure that there's some protection from the weather. So eaves on the roof, something like this will be good. A garage is also a perfectly good location as well. We also ask that you have a clearance between the equipment as well. And we also ask that you that you install it straight. Don't install it in a tilted fashion. I had someone ask if you can install it upside down, and the answer is no for that one. So make sure that it is upright and against a surface that's flat like that. In terms of the mounting, what it looks like is that there's a bracket that you bolt onto the wall, and then you bring the ELS 11.4K, and then you hang it onto the wall as such. And then there's a locking screw on the side. To open the panel of the ELS 5K to the ELS 11.4K, sorry, to do the wiring is pretty simple. You have two screws on the bottom to lock it, and then there's also a buckle that you can undo to open up the panel and easily access into the inside. So next, I also want to go over the EMA mobile app. So just as much as the batteries and the PCS is an integral part to the product, another important part to the product as well is the app. So I'll see how this works. I'm going to try to play the video. Oh, it works great. So this is the app that the homeowner will have access to. So as you can see, this is live data that you'll be able to see the system working. So in this example over here, we have around 2 kilowatts of solar, 1 kilowatt charging the battery. The home is currently using 800 watts, and the excess power is being exported out to the grid. And you can see on the top that the battery is 80% charged right now, so it's going to be increasing as time goes on. So if you switch over to the right, you'll also be able to see the historical energy readings, so the accumulated values. This portion over here shows the microinverters that are installed with the system. So once again, it's great that it's all in one. You see micro data and storage data. This is data that is shown on the system here. So if you notice in the beginning, I'll pause right over here. In the beginning, when there is no solar, the battery is actually the battery is not being used at this point, and power is being imported from the grid. My guess is probably because the battery was discharged during this time, so the battery wasn't being used to output loads onto the home. And from here, this is basically where you get to see solar begin to kick in. And then the green section is the charging of the batteries. And then the dark orange section is the excess power that is being exported. And then the blue section over here is power that is being, or energy that is being consumed. So let's let it play out a little bit more. Yeah, so in this case, the customer is not using the grid. This is over here where you can set the system modes. So the customer will be able to set the system modes of how they want the batteries to function when they're on the grid. So I'll pause here and I'll talk a little bit more in detail on what that is. So, all right, I'll talk about the modes of operation. So these modes of operation talk a little bit about how do you want the batteries to discharge and charge when they're connected to the utility. So the first one is backup mode. So the main priority of backup mode is I want to keep the battery as full as possible so that when I lose the grid, I will have maximum battery to back up my system. So what that basically looks like is that on the app, the system will do whatever it can to charge the batteries. So in this case, you're basically charging the batteries, currently discharging from to the grid. There's a little bit of solar that's being powered to the home, and the grid is being outputted to the home. So once again, what's going to happen is that no matter how the home is consuming power or things like that, the battery is just going to be charged to a point where that it is full. So that what happens is that when you do go off grid, you will have maximum battery capacity available. So this is basically an example of what happens when you do lose power. So in this case, you lost connectivity to the system, to the utility, and as a result, the home is going to be consuming power from the batteries. In this case over here, you will actually have some solar that is available. So it's going to be taking both solar and the batteries to power the home loads. And then in this example over here, if you don't have any solar, not a problem. You still continue to use the batteries to power the home. And if there is a time where if you lose power, or rather if you are using less, I guess in this case over here, say that you're using less than 1 kilowatt of solar, let's say you're using 500 watts. So what will happen instead is that the excess solar will be charging the batteries so that the battery will be able to get a little bit of juice even when they're in a power outage. So note that this off-grid backup behavior will happen no matter which mode you pick. So no matter what, if you lose connection to the utility, their batteries will begin to back up in this sort of a way.
We do have a question, Chris, actually.
Yes, go ahead.
Tanner says, if we have 20 times DS3 pushing 3.7 amp each for a total of 74 amps on 100 amp service, 80 amp max, and want to add a battery, do we have options, or is it going to be too much for the main 100 amp breaker when we consider the battery also being a source, or will the PCS limit the output to the grid?
Oh yeah, that's a good question. So I will answer it in so I'll talk about this a little bit more in detail in future slides, but I'll say these two quick things. One, it is possible to put solar not directly into the inverter, but you put it onto the main panel. If you don't want to overload the inverter charging. I'll talk about what that looks like in the future, in future slides. The second question is, or the second point I also want to make as well is that yes, it is possible to limit the current that the PCS will be interacting with the utility. The system will be UL1741, so a PCS power control system. So it is possible to limit the current. I don't go over that in this presentation, but it is possible to limit the current between the main panel and the PCS.
Great. And then we have Ross asking, is APS offering a split phase consumption meter that integrates with solar and the ECUR? I see the battery system does not have this metering.
So actually this, if you purchase the APstorage solution and you install it, you will be able to get all the consumption and solar information. I will also show this in a future slide where I go over the schematic diagram of how things put together. But when you install an APstorage solution, you will be installing CTs onto the system that will allow you to get consumption data and microinverter solar data, as well as import and export data as well.
Great, thank you.
Mm-hmm. Yeah, no, these are fantastic questions, so thank you very much. I think Karen and Voss for asking those. Apologize for butchering your names. So in any case, the first thing we were talking about, so the first one we were talking about was backup supply mode, which means I want to keep my battery as full as possible. The second mode is called self-consumption mode. So self-consumption mode is I want to minimize grid usage as much as possible, and I want to use the batteries and solar as much as I can. So what that basically looks like is when so say for example, you have the home is, oh, actually, let me take a look at this. Yeah, this is correct. Yeah, okay. So, oh, actually, no, I think this is incorrect. Yeah, so I actually have the screenshot on the left side for when it is working in advanced mode. So I will, let's see. I'll stay on this slide and I'll try to use my laser pointer to describe what's going on. But I apologize in advance for the incorrect screenshot. So as mentioned earlier, self-consumption mode, what it's basically going to do is it's whenever the home is using power, it's going to use solar and batteries as much as it can and try to limit grid usage. So in this scenario over here, the home is using 3 kilowatts, so it's going to be pulling power from the solar and pulling power from the batteries. So say, for example, now this home, instead of using 3 kilowatts, so let's say it's using 1 kilowatt. So in this instance, instead of solar, solar will be providing power to the home, so 500 kilowatts, or 500 watts, and then the extra solar is going to be charging the batteries going down this way. But say, for example, it's during the nighttime, you don't have any solar at all, and the home is using 3 kilowatts. The battery is going to be continuing to power the home because, once again, self-consumption mode says, I don't want to use the grid as much as I can. I want to use batteries and solar. So the batteries will continue to push power to the home. And then as soon as it hits a programmable threshold, so say like 50% of a state of charge. So when the state of charge hits 50%, then the battery will stop discharging, and then it will have no choice but to use power from the utility to power the home. Now, once again, you can be as aggressive or conservative with your SOC limit. If you do 30%, then you're going to be using the battery a lot more. And then if you put 70%, then you'll be using the battery a lot less, and you'll be pulling power from the grid a little bit more often. So once again, so just to summarize, self-consumption mode, I want to limit grid usage as much as possible. Now, the third mode, we call it advanced. We have many different names for it. We call it advanced mode, peak valley mode. I personally like the word time of use mode because time of use mode implies that there is a certain amount of hours where the grid is expensive and when the grid is cheap. So this is particularly useful for utilities where they have peak hours and off-peak hours. So what you can do is you can schedule the peak hours and off-peak hours so that when you're on peak, so when the grid is expensive, I'm going to use the batteries and solar as much as I can. So it'll be in self-consumption mode. But when you're in an off-peak scenario, so when the grid is cheap, I'm going to use this time and opportunity to take power from the grid and charge my batteries. So once again, this is very useful for time of use modes when you're trying to offset energy costs and basically do energy arbitrage. And this is basically what the time settings look like when you're on the app. So you can basically use the time to sort of drag the schedule that allows you to pick and select the charge times and discharge times. So that the discharge times is when the grid is expensive and the charge times is when the grid is cheap. So once again, all three of these modes are settable not only by the installer locally, but it can also be set on the website remotely. And furthermore, in the homeowner can also set these modes as well with the EMA manager, with the EMA app that they have. So an interesting use case that you can do is, say for example, you know that there's going to be a huge weather event and you have concerns about the resiliency of your home. So say you are normally in self-consumption mode, so you're using the batteries to provide power, but you notice that there's a weather event that's coming, so you're going to go into your EME app, set the mode to backup mode, so that way the batteries will begin to start charging. And when you do actually lose power, you will have maximum state of charge to back up your system. Right,
We
and
do
just
have
as
a
a quick
question. Oh, sorry.
yes. No, go ahead, Matt.
Jeff asks, is the system designed for whole home backup or more tailored to critical loads?
I will go over how to do a whole home backup solution. I would say that in general, it's probably better to do this as like a critical load center, to have a critical load center. But it is possible to do a whole home backup with a transfer switch. And I have a system diagram at the end of the presentation that shows how that is done.
Thank you.
Yep. Thank you very much, Jeff. All right, and just as a quick overview, this is basically what the system diagram looks, or not the system diagram. This is what the EMA website portal will look like when you have APstorage at your home. This is the installer view actually, so this will allow you to do remote control and monitoring. So if you want to do any sort of debugging on the system. Okay, so I'll first now go over the system wiring. These are the components that will come with the kit. So obviously it will come with the PCS. You will also have the bracket, some screws. This is a dongle that basically allows you to connect to the system via Bluetooth. We'll have the DC terminals for the batteries, some CTs that allows you to do the consumption and production monitoring, the index, and then we also have some a magnetic ring. It's basically for EMC control of the DC wiring that you would do in this way. And this is what is supplied on the battery side. So it's basically the battery, you'll have power cables, a grounding cable, a communication cable, and an additional hardware for the system. And then this is what the system diagram looks like from a wiring perspective. So this is where you plug in the DC wiring. This is where you plug in from the main panel. This is the backup portion. This is backup was just relabeled as load. 3 is where you put in the solar that you want to have function during off-grid. And then this is where the communication between the batteries are done. And then this 7 over here is the location of where you plug in the CTs. All right, so now I'll go over the actual system wiring and what it looks like. So this is one configuration on how to install a system. So once again, you have the main panel here that's coming from the grid, and then you have a backup panel over here with all your backup loads. So there are basically 2 ways that you can connect solar to the system. The first way is to connect it into this port directly over here, the off-grid terminal. By doing so, you will basically have solar continue to produce power when you have a grid outage. But the main downside is that if you have the inverter connected, if the inverter is connected here, the solar inverter is connected here, there was going to be a limitation on how much solar they can put in here. This quick graph basically describes the maximum amount of solar they can put on that port. So it's going to be 14 kilowatts of AC onto the off-grid port. If you just have one battery, it's going to be half of that. But if you have 2 of the DC batteries, no, I'm not talking about the inverter or the PCS. I'm talking about the batteries. If you have 2 or more, then you'll be able to put 14. But if you just have 1, then you'll be able to put 7.6 kilowatts AC. So this is the reason why we generally recommend having 2 of these 10 kilowatt hour batteries. Now, the other way that you could connect solar is to do a pure AC coupled way. It's just by connecting it instead of the PCS directly, is to connect it into the main panel. If you do it this way, there's no limitation on the size of how much solar that you have. But the main downside is that when you have a grid outage, this solar will not be able to stay on because 240 will be gone on the main panel. So a lot of times, a lot of customers are often asking, like, say I have for example, a 30 kilowatt AC system, what would you do? Because you can only put 14 kilowatts AC onto the PCS directly. So what you would do is that you would split them out. So you would have the PCS connected to half of the inverters on the off-grid directly, and then you have the other half onto the main panel. If you do it in this way, you will have the entire array available when you are connected to the utility, but then when you have a grid outage, you will just have half of the array available to charge the system, once again to prevent the PCS from overcharging its solar. And I'll just do a quick competitive analysis. A lot of people often ask what the difference is between, for example, Enphase's and our system. So I would like to sort of do like a system comparison right over here. So with Enphase, in order to get we're going to design a system with 11 kilowatts of backup, 15 kilowatt hours of capacity, and let's do 14.4 kilowatts of solar. So the entire BOM cost basically boils down to this, where you have 3 5P batteries to get you the 15 kilowatt hours. You have a system controller, and then you have an IQ combiner for the micros. And then since these are 30 panels, you basically need to have 30 micros for each of those panels. If you were to compare with our system over here, the equipment that you would just need to purchase from APsystems is going to be 2 kilowatt hour batteries, 2 10 kilowatt hour batteries for 20 kilowatts, and 11.4K PCS as the inverter. And then you would also have half of the number of DS3Ls because you're doing multi-module connections to the panels. And this is sort of the system comparison between the two. All right. Let me double check my slides here. Okay. All right. So I think these are going to be the final 2 slides that I will have. But this is basically a electrical diagram in a system line diagram on how a system would look like. So this is a essential load backup system. So kind of similar to the previous images, but done with like circuit breakers. And what we have over here is we have the utility going into the main panel right here. And then you have a breaker going into the grid port of the PCS. And then you have the output of the PCS load going into the backup panel. And then you have solar going into the system directly like so. There was an earlier question on consumption monitoring. So this is how it is done with the storage system. You would have grid CTs plugged in right over here to measure the input and export power, which then it will be able to measure consumption power as well. So this is, in my opinion, probably the recommended installation that I would recommend, because this explicitly shows you're able to explicitly divide and divvy up which loads you want to back up and which loads you would say are going to be non-essentials. This is the diagram that I have for if you want to do a whole home backup type system. So what's going on here is that I have a transfer switch over here that switches between what is supplying power to the main panel. So this is the main panel over here. It's going from the transfer switch, the output side. And normally when you're connected to the utility, it's going to be switched into this section over here, and the utility is providing power to the main panel. Now the PCS is going to be line side tapped into the utility over here. And in this configuration, you'll be able to use the batteries to push power onto the loads if you're on self-consumption mode. And it will also be able to charge power from the solar as well. So if you have solar directly connected here or connected in here, it will be able to take the solar and charge it, charge the system. So, so that's the purpose of this line side tap. So now, say for example, you lose power, the utility is gone, and you're going to have no power anymore over here. What's going to happen is the battery or the ATS or the transfer switch is going to switch over to the backup, and then the PCS is going to be backing up the entire main service panel right over here. The main thing that I do want to warn is that if it does go into the backup, if the main panel is exceeding 11.4 kilowatts of power, the PCS will shut down to protect itself, to prevent it from overloading. So it's going to be important for the customer to know that when you are in a backup scenario, to make sure that you are only using the essential loads when you're powering on the system. So I would almost even recommend maybe having a manual transfer switch so that the homeowner is intentional about knowing that they are in backup mode and they need to adjust their usage behavior as if they were in backup mode. So in any case, that is the last slide I have for you all. So once again, thank you very much for attending this webinar on the ELS 11.4K. And I guess I will leave the remaining, 12 minutes of this webinar for questions. So yeah, Matt, I see you unmuted yourself. Do you have any questions?
Yeah, I don't see any at the moment. Anybody have any questions? Great opportunity while we have APsystems with us.
More than happy to continue to hang out with you all.
Okay, I don't see anything, but obviously if you folks do have follow-up questions, please reach out to your BayWa reps. We'd be happy to help you out. And once again, thank you. Oh, here we go. Can the batteries operate in minus 30 degrees Celsius?
Let me take a look. So if it is -3, what will happen is that the batteries will begin to heat itself up. So that it will not go down to minus 30. But I don't believe it will be able to do minus 30 if it actually does end up being that cold.
And then we're being asked about pricing. Jeff, just reach out to your rep. I believe we have pricing for these products currently. So just reach out to your outside sales rep and we can definitely get you that pricing. And Mark asks, is the system compatible with all the previous APS inverters, i.e. YC500s?
Yes, it is.
Okay.
That's the beauty of AC coupled.
Okay, I think that's it for questions now, but once again, thank you, everybody. If you haven't signed up to our web shop, we'd like to encourage you to do so. It's a great resource. You can find specs, pricing, install manuals, availability, all on there. This was recorded. We will be pushing this on to our YouTube channel shortly. So, and it also will out in the monthly newsletter. And thank you very much to APsystems, and thank you, Chris. Really appreciate our decade-long relationship, and looking forward to continue on.
It is our pleasure.
Thanks, everybody. Have a great day.